area versus number line. So talk to us a little bit about that.
So we were really interested in understanding, if kids could get more out of a very brief instruction if it was presented as a number line instead of the sort of more traditional area model. So usually kids are first introduced to fractions in, about second or third grade, and it's the first introduction normally is with like dividing a circle into pie pieces, for example. But there's a lot of research on using the number line to show fractions and whole numbers as well, and how that can be really beneficial. But all the research in the area of fractions so far had been, showing that kids who can already put fractions on a number line tend to do better. And we wanted to see if actually teaching fractions on a number line was helpful. So what we did is we divided the kids, these were second and third graders, into 3 groups. And one group got a 15-minute fraction lesson about how to place fractions onto a number line. The second group got a lesson about how to shade a circle into fractions. And the third group got a control condition, which was just doing crossword puzzles, because we wanted to see, if they weren't doing anything to teach them fractions, how they would do. And so we, in each group, got a pre-test and a post-test on their ability to place fractions on number lines and circles. And also, our most important task was being able to just compare fractions. So for example, being able to say which is more 2/3 or 1/4. And we didn't actually teach any of the kids that. So we wanted to see if teaching them about fractions on the number line would actually help them to be able to compare fractions better. And in fact, that is what we found. So at the end, at the post-test in the study, the kids who got the number line fraction training actually were able to compare fractions better than kids who got the area model circle training and then the crossword puzzle kids.
When you shade the number line, they can actually see it. Did you hypothesize that?
So we expected the number line to be better for those reasons that you just said, because it's organized from left to right, and kids already have some ideas about how smaller numbers go on the left and larger numbers go on the right. They might have those ideas from working with whole numbers, and now they can apply that sort of left to right, smaller to larger, to understand how fractions are related to each other in terms of their size. And as you said, we also shaded the line from 0 up to the fraction, and that length information could also give them a sense of the size of that fraction. And of course, in the area model, we also shaded the area model, but it's not as well organized in terms of how the fractions relate to each other, because in a circle, it doesn't really matter which quarter you shade, for example. And it could be 1/4 one time and a different quarter the next time. But in the number line, it really matters, and you have that ordering information starting from 0 and progressing from left to right.
Parents who are trying to teach their kids concepts like this or reinforce them at home, would you advise using a number of different variant ways of teaching?
Well, I think this was just one study, and I think that it suggests that kids are capable of learning from number lines. I think a lot of, even at a very young age, even in second and third grade, when their fraction understanding is very minimal at that point. And I think sometimes people shy away from what they might think is a more complicated representation, but actually it really draws on a lot of their knowledge. So I think that what I think our study shows is that introducing number lines to teach fractions earlier could be beneficial. But I do think, as you said, that using multiple representations can also be really helpful, teaching number lines and area models and drawing connections between them. And those aren't the only 2 representations for fractions, of course. So I think there is some research that, by other people suggesting that multiple representations and making connections between them can be really helpful.
When you were actually out there testing the kids, did you see some aha moments where they looked at it and they got it?
I think that it's hard to say. It's not always really obvious. I think that they actually didn't, even at the end of this, they're second and third graders. They don't really have a very strong understanding even after our 15 minutes, and we didn't really expect them to. This isn't a curriculum, but it did still have a significant effect in terms of them doing just a little bit better than the other groups that were taught a different way.
What motivated you to do this particular study?
Well, so I think I mentioned the previous research on the number line. There have been correlational studies with fractions and showing that kids who can place fractions onto a number line that's correlated with better performance in fractions, better performance in algebra. So it seems like it might be helpful, but nobody at that point had really done an experiment to show a causal relationship between placing numbers, fractions onto a number line and doing better. So that was a really big part of the motivation. And we were also drawing on other research with whole numbers that had shown both that correlation and a causal relation. So teaching kids how to place whole numbers on a number line in these experimental contexts, for example, playing board games like Chutes and Ladders, where it actually improves your kind of number line representation for whole numbers, and that can then improve other aspects of your number concepts. So we were kind of transferring from that to the fraction domain to see, can we show this causal relationship between placing fractions on a number line and kids' fraction magnitude understanding.
What do you really hope to prove by this?
The first study is actually already analyzed and published. I think we were talking earlier about a follow-up study that we're still working on. We're trying to understand what are the cognitive underpinnings for kids' concepts, what kinds of representations are most helpful for their learning, and why. And so this is a first step, which one is more helpful, but our second step that we're following up on now is to try to understand why. What is it about the number line that's helping them? Is it the fact that it's organized in this left to right way? Is it that it's organized on a single dimension, the same way that real numbers can be organized on a single dimension? These are some of the factors that might be supporting kids' learning, and we're trying to piece those apart in our second study that's ongoing.
At the end of the day, all of this is to help everybody learn better, and also to help the parents help the kids.
Yeah, it's definitely, I think the big picture goal of my research is to understand, how kids learn in order to inform ways to help kids learn better. And, I think that these kinds of findings are things that, if they're replicated and supported, could be used by curriculum developers to suggest that maybe they should be incorporating these number lines earlier, and can be used by parents if they're doing activities with their kids at home.
In today's technology and fractions being utilized, is that always going to be a transferable skill and an important skill for children?
I think that math in general is always going to be an important and transferable skill. I think even if you aren't going into a STEM job, I think it's really important to have an educated populace that can understand statistics. You have to make medical decisions. You have to make financial decisions. I think having a good, solid math background is really good and important as a citizen. And I think it also really opens up opportunities for kids to, if they have that solid math foundation, then they have more opportunities to go into these, more, high status and lucrative STEM jobs that are, kind of booming, and especially in computer science, but in other areas as well.
A couple of tips that you would give parents.
Well, I would say that, kids even in second and third grade can learn about fractions. It's not too early, and doing that with a number line can be really helpful. That's sort of the most concretely related to our study. But I think that, generally, supporting kids learning at home is really important in math, and helping kids to believe that they can always improve their math ability, and that math is something for everyone, not just for some kids.
Your educational background, undergrad, grad, and PhD.
I received my bachelor's degree from Yale, my PhD from the University of Chicago.
Tell me about the specifics, how many kids involved, ages?
Yes, in our study we had 114 kids. They were second and third graders. The study was published in Developmental Psychology in 2017.
How long did you study them? They
were studied over the course of 2 sessions, usually about a week apart. Each session was only about half an hour.
Who funded the research?
The National Science Foundation.
Based on this study, what do you think needs to be looked at next?
I think that as I mentioned earlier, we're following up to look at what aspects of the number line are sort of driving these effects. Is it about being organized from left to right? Is it about being organized on a single dimension? And also trying to understand, how generalizable are these effects? Can you get even bigger effects if you do, our intervention was only 15 minutes long. If you incorporated this in a longer time frame, would you really boost kids' learning that way?